This video is a quick review of the likelihood function. So here's the setup. Let's say that we've got some xi's, 3 of them actually. They are Bernoulli random variables. They are independent and identically distributed, and each of them have this distribution. So the probability that I get a 1 rather than a 0 is pi. So this pi here does not refer to 3.1415. We're using the symbol pi like any other Greek letter, like theta, or any other English alphabet letter, like X or Y. So this pi just represents some unknown value representing my probability that xi is equal to 1. And you've got some choices. Which of the following describes the likelihood of these observations? And the likelihood, often written as a parameter, as a function of our parameter pi, is the probability mass of observing our actual data, assuming our value of pi. So sometimes you'll see this conditioning on pi written as part of the probability as well. If the xi's are independent, then we can decompose the joint distribution, and we often work with log likelihoods so that this product turns into sums. The reason is that oftentimes we'll want to find a value of pi that maximizes the likelihood of seeing our data, observing the data that we've observed. So this is the idea behind maximum likelihood, which we'll talk about during class. So let's write down as an example, the likelihood of observing these xi is always 0, and I've observed 5 of these xi, so x1 up to x5. And my setup here is still the same. So each xi is independent, identically distributed, and the probability that I get a 1 is pi. So let's write down my likelihood. Well, my likelihood, that's just going to be the probability that I observe these 0 values 5 times. I will write down the given pi here, and I can decompose this, right? I can decompose this into x1 is equal to 0 times probability that x2 is equal to 0, and so on. And here, I was able to do this because of the independence rule. And now I can also plug in the actual probability. So what is the probability that x is equal to 0? Well, that's going to be, based on my parameter here, 1 minus pi. This one is also 1 minus pi. So, and I've got this 5 times, right? So here I'm using the distribution, the fact that the distributions are identical. So my likelihood is 1 minus pi to the power of 5.